Hello guys, I swear to God, I've recorded this video 3 times. I hope it works this time around, guys. Well, I'm going to be making a video on how I essentially saved $480 a month on my cloud bills by switching from GCP to Hertz now. All right, guys. So I'm going to go over the landscape of software development right now, essentially how you can host your apps, the options that are available, and essentially what inspired my decision to move off GCP. All right. So I essentially started my hosting journey with platforms like, actually, I need to mention them, Netlify, um, you know, Vercel, Firebase, Superbase, um, Convex. Um, there's a mixture of both backends as a service here and um, hosting. Like, just you want to host like a website, like Netlify is generally for hosting, right? I can also put Cloudflare here as well. Cloudflare, right? These are the like um, first layers when it comes to hosting, and they work, especially if you're doing anything for a mobile app. You're going to use Firebase for something, either the um, notifications, right? Firebase notifications, or any of the mobile specific services. But as you move on from JavaScript land and start writing other kinds of programs, like you learn a real programming language like Golang, you tend to have other needs that Firebase cannot directly address, right? So this was what specifically led me down the GCP cloud engineer route, because I started writing Golang code and I realized Firebase doesn't have a place to host Golang code because Firebase Cloud Functions run on JavaScript. So I learned GCP, learned about Cloud Build, Cloud Artifact, Cloud Run. These are all managed services that can spin up a server for you using any programming language with the power of Docker. Um, but it's not a persistent service. It spins to zero when it's not being used, and it generally only works over HTTP. So you can't run background tasks on it or cron jobs on it. But guess what? They have a platform for that. So yeah, I quickly ran into a bottleneck with GCP specifically this year, and I'm just going to show you guys some of my daily history. So as you can see, everything was all good. I was being charged $1.03, and then I decided to move off Firebase and host my own database on Postgres Cloud SQL, right? So GCP has a cloud database service that essentially handles everything for you, right? So, the bill started increasing, as you can see, 1696. The last bill is like 96. I still haven't paid the last bill, guys. So I kind of realized that it wasn't going to be sustainable for my needs if just one of my app is um, taking this much compute price. I haven't even added any, at that point, I haven't added any cron jobs yet, which I needed cron jobs. Um, I would have had to do that with using Google Cloud Scheduler, which would then call an open endpoint on my API, a public endpoint on my API, which is a whole lot of security risk. Yeah, it was a lot. So at some point this year, I got inspired to essentially check these guys out. Hetzner, I can't pronounce that name, guys, but Hetzner. And then they led me down the journey of essentially setting up my own server, and now I have set it up. I'm here to make the process easy for you, so you don't have to go through all the stress. This breakdown is specifically tailored towards Golang workflow, but it would equally work for any workflow. Once you have the server set up, you can install any programming language you use on it, Node, Python, whatever. But for this example, we will not be installing any programming language because Golang can compile to binary and we don't have to install anything. Anyways, guys, this is how the video is gonna go. So let's say you're on Hetna site and you're about to purchase your web server. During the time of purchase, they may ask you for your SSH key. So you're to essentially give them access to your public SSH key. So you would copy it. I I need to confirm that. I think it's the public key, not the private key, but it might actually be the private key. No, but I'm not sure. But you would copy your SSH key, one of the pairs, because there are two pairs. One stays on your computer, and which is the private key. So yeah, the public key goes on your server. So when you have created the key and you copy it, um, and you have set up, you have purchased the server, you can then access it by using SSH. So you can SSH into the roots of the IP address because they will give you your IP of your machine. And if you press this command, you would instantly be logged into the machine. How this works is that the key you generated, your computer kind of uses it to form a handshake with the server, and they confirm that yes, this person with this private key has the right to access this specific server. That's how it works, right? So it all does all of that behind the scenes. So once you have access to the server, you're just going to run a fresh update. APT is like a command, sorry, it's like a package manager, kind of like npm, but for Linux, right? So you run this command and it just refreshes your server and stores anything that's old. If it's an old machine, it just makes it fresh. So you can then start doing all the things you need to do. So the first thing you do after the upgrade and update command is you would create a new user, right? So you create a new user called deploy. In this case, this user is called deploy, but in your case, you can name your user anything you want. And then the next command is that you will give deploy admin privileges. So deploy can access admin privileges using the admin password, right? So if you follow this step, um, deploy can have access to admin privileges, right? So you would I think it will ask you to put in a password. I'm not sure. If it doesn't ask you, there's a step you need to put in a password, guys. So when that's done, you then resync your key, right? So you're essentially copying the key to your deploy um, user. So you're essentially copying the key from the root to your deploy. Um, once that has been done, I think this step two, I can't remember. I can't recall. I think this step 2 creates your password, right? It asks you to put in a password. So ensure you have that password before this next step, or else you might be locked out of your system. But this next step is essentially we're creating an SSH rule that forbids root access and then also forbids password access to your server, meaning you cannot access the computer with a password. You can only access with your SSH key, the one that you just copy to this new deploy user, whatever name you used for your user. So once you have that, you will then restart the SSH. So these rules will then be applied. The next thing we're going to do to secure the server is set up the firewall. So for the firewall, the first thing we'll do is we'll deny all incoming traffic, and then we'll enable all outgoing traffic. Once we have done that, the next thing we will do is we would allow 3 specific ports, only 3 specific ports. We're going to allow port 22 for SSH, port 80 for HTTP, and port 443 for HTTPS. If your server has more unique needs and needs more unique ports, you may expose those ports. But for the most part, these are all the ports you will generally need for any application. So once you have exposed those ports, we then enable these new rules. So yes, boom, we have our firewall up and running. So the next thing we're going to do is we're going to install a reverse proxy. So now we have our firewall. Nothing can access any other ports in our system. They can only access the HTTPS ports, the SSH ports, and the HTTP ports. So now we need a reverse proxy that listens on the HTTP and HTTPS ports and then routes traffic to the specific services. That's where CADI comes in. So these are the steps to install CADI according to what I did on my server, right? So essentially, you would install core, then you fetch the keys, then you fetch the core text files or like the actual files you need, and then you run the updates, and then you run the install. Now, I don't think you may have to run all these steps, but these were the suggested steps. I would assume just this last step would work, but I think you should just follow all the steps just to be safe. Um, Once you have CADI installed, you can check to see that it's running. So you use the sudo system ctl to check if it's running. And the way this essentially works is that the sudo ctl allows you to check services, to start them, to stop them, to check your logs. You can use the log CTL to check your logs for your specific apps. So we'll be using this command a lot, but this is your first introduction to it. So once you have CADI installed, right, it sets up its service by itself, right? And it creates all the files, all the configs. Like you don't have to set that up. But when you're running your own app, you would have to set up the service file and the config file, right? So you can check the CADI config. It should be located at this specific location. If you check it, you should see something like this. It should serve you an empty welcome screen or something like that. Welcome to CADI. To ensure this works, um, you need to point your you need to point your you need to edit the file, right? When you edit your file, you change your domain. So you put the domain you want. You have a domain you have access to ideally, right? So let's say you have access to domain.com, you put domain.com, and then you point the a name of the domain.com to your IP address. So once you point the a name to your IP address, then you can, oh sorry, the CND name. Yeah. Once you point the CND name to your IP address, then if you access that domain, you should see hello from the Caddy server, right? So obviously, if you edit this file, you need to reload Caddy, so this edit would take effect. So if you have reached this step, ideally you should see a secure HTTPS response from your server. Caddy handles all the certificate renewals and all of that stuff, so you don't have to think about that. So the next thing we're going to install is Postgres. Now this one is a bit simpler than Caddy. Is you just install sudo apt install Postgres, and it does everything. It installs the service files, and it runs and starts and enables the service. So after it's run, you should be able to check the status of the Postgres to see that it's running as a service. So now we have two things done, the reverse proxy, and we have our Postgres installed. So the next thing that we're going to do is um, we're going to install an app. But before we install the app, we need to talk about the service file, right? Um, the service file is essentially how the system knows what a service is. And it's essentially a small text file that describes um, what the service is, how it should run, what the who is deploying it, what the service requires. So you can essentially take a look at this file. I'll explain this in more details when we deploy our very own app, but this is essentially the service file. Now, the service file for apps that we install using the APT generally end up here in the library folder, whereas the ones for the app we create ourselves usually end up here in the etc systemmd/system. So there are two different locations. So keep that in mind. I think these are just standard Linux best practices. So yeah, I'm just following those that have here before me. So we're back to the deploying of the app now. So to deploy the app, right? We should first check if we have anything running on port 8080 because we're going to deploy our app on port 8080. So on our server, all this we're doing it on our server, right? So we're going to run these three commands. And what these three commands do is essentially it creates a specific user called my app with a randomly generated hex password. It then uses that user to create a database still called my app. So owned by that user. So that user has access to the database. Boom, simple. We then create our environment variables, which as a default would, it's localhost because our app doesn't actually talk to the internet directly. It's using a reverse proxy, right? So it's a localhost. Then we're speaking to our database in the same server, right? So we're giving it the port, then the name, the username for the Postgres is my app. Then we copy the randomly generated password. The database name is my app, and then the port we're using is port 8080. If you code Golang, this is very common practice, right? This isn't new to us. Then obviously we have it, excuse me guys, we have a base URL, which is the base URL of the app you're specifically building. And then any other environment variables you need, like Stripe, any other thing, right? You add everything to this specific file. Once you have done that and you have saved the file, you then run this command, which is essentially setting the permissions access to this file. So what this command means is that only the root owner has access to this file because it's saved under the roots. As you can see, /etc is under the roots directory. So only the root has access to read and edit this file. Any other user doesn't have access to any of our environment variables. Cool. So the next thing we're going to do after that, we're going to create our service file called myapps.service, and we're going to give the app these basic descriptions, right? So my app, so after network has been like initialized and after Postgres has been initialized, that's when I want you to run this service. It's being deployed by our user deploy. You can use any name or the name you used for your specific user. The environment files are under etc.myapp.env, which is the same name we used here. So whatever name you use here is what you would essentially point the service to. Then the execution starts. This just means what binary are we going to run as this specific service. So it's going to run whatever it's on deploy.myapp. Right now we don't have anything on our home folder of my app of this specific user. We don't have anything there right now, but we'll soon push our app there. And then restart always. That means if anything happens to this service and it should crash, it should restart it after 3 seconds. That's what this means. Then wanted by multi-user just means this would run on boots. That's what I understand though. This would run on boots. So once we have that, we run sudo systemcl reload, daemon reload. So this just essentially would fetch all our configs. It will fetch all this, our new service, and then sudo enable my app would essentially enable this my app. It doesn't start the app. It simply enables it. If you go up back here, you can see I mentioned some of the commands of sudo. You can start the app, which means start now, or you can enable, which means it starts on every boot. So since we had, obviously our server hasn't shut down or had to reboot, enabling it doesn't start it. It just enables it. So we still have to start it later. So the next thing we will do is set up our domain for our service. So if we have, we open our caddy file, and then if we have access to the sub domain of api.example.com, we then put that there and put the reverse proxy to our localhost port 8080. So what this means is if anyone on the internet goes to api.example.com, it would fetch our app. It will serve our app. It will serve whatever is hosted on port 8080, if that makes sense. So to ensure you ensure you have your DSN or else this step wouldn't work. So go to your domain, register, add a DSN record. If you have access to the whatever your domain is, you use your specific domain, and then you point it to your server IP address. So the CND name or CD name to your server IP. That's all you have to do. And then Caddy handles the rest. So what happens is that when someone goes to your domain, it sends a HTTP request to your server, which Caddy sees, reads the domain name, knows that this is expecting to see the localhost 8080, and then it serves the localhost 8080 along with the certificate. So it does all of that for you guys. So it's pretty awesome. Um, so yeah, the next step is to actually deploy our app now. So this is why we love Golang over here, guys. So on your local machine or your MacBook, right, or your computer, you would open your code base, your Golang code, and you would use go build to build for Linux. So this is the command you would use specifically to build, and the output is going to be my app. So once you have that built, you're going to use this scp command, which is almost like the SSH, one of those commands you have access to that allows you to do things with a server, but this allows you copy files. So this is going to copy my app to my deploy server. So this my deploy at my IP in my home directory under deploy/my app. This is the same target we used here. If you pay attention, it's the same target. So once we have deployed that, we can then start the app because we then have the binary there. We just start the app. So once we start the app, we can check the status and we can see that it's running. Once you see your app is running, you can confirm the domain. If the domain doesn't work, check your CADI file, check your DNS, and it should work. So you sorry guys. So you have updated your code, right? And you want to push another update. So how do you push another update? All right, cool. Same thing. You build the new update. And now you use the same copy command, but now if you note there's a difference. You're copying my app.new, whereas initially it was just my app. Now, why? Because you already have a my app on your server and it's currently running. So you cannot copy on top of it. You have to copy to my app.new. Once you have copied to my app.new, you then have to SSH into your server and then run this command, move. So the move command essentially is going to rename the current my app.new. So it's going to, yes, it's going to rename the my app.new you just uploaded to my app. Whereas the previous my app that was running still continues to run, but it's no longer named my app. It's the pointer of my app has moved to the my app.new. So once that happens, once you restart the service, it runs the new binary because the new binary has been renamed to my app, if that makes sense. So you're essentially doing a switcheroo. So you're bringing the new one, naming it .new, while the old one runs, you switch the name to this is now called my app, whereas this one might not even have a name again. And then once you restart it, it runs my app, which is the new one. So that's how you deploy your new code base. So you can see it's pretty straightforward. So now the next thing is probably wondering how can I deploy this on GitHub push? Like I want to deploy it when I push to GitHub. So this is the next step. I'm going to break down. So there's this command that we're going to run, but before I explain this command, let me just go down and explain the GitHub workflow that we essentially worked on. So this is the GitHub workflow. So this is how it works. You're deploying, the name is deploy backend to my server, right? It triggers when you push to my main branch, and it runs the following jobs, right? The job deploys Ubuntu, it loads my app, right? It loads my app, it loads my code base, it loads Golang, right? Onto this like workflow machine. But essentially, GitHub spins up like a disposable container that runs this. So it installs Go, it runs everything, it installs Ubuntu, installs Go. It then runs my specific build command, as you can see, the same one we run on our local machine. And then it loads the SSH keys from a secret that we haven't yet added, but it will check this specific environment secret. And then it would essentially deploy the keys and then use the key to restart, to deploy the app and restart the server. So it uses the key right here to deploy the app and then restart the server. So let's break down exactly what this command is. So what this command is that we're creating a rule, a very specific rule. And this rule essentially says any any deploy user can, without a password, run this specific command, this system control restart my app. And then we save the output. So we saving it here under etc sudoers.d my app deploy. That's where we save this rule. Then we obviously make sure this rule can be read by people, the owner and people in the group. And then this last command is just to syntax check the rule to make sure that there is no problem. Once we have this rule deployed, we can create a key under the deploy user and give that key to GitHub. GitHub can then use that key to SSH into our server and to upload our app and to restart our server. So this next step, I'm going to explain to you how to essentially generate a new key. It's the same way you generated your own key, like the one you currently use. You just create another one. So you create another key specifically for the GitHub workflow. You can name the key my app deploy. Right. As you can see, the rules. You teach your server to accept the key by running this command. So this essentially copies the key information to your server. And then you copy the private part of the key to GitHub. This command does that for you automatically, right? This command does, but if you don't have the GitHub CLI installed, you can do it manually by essentially you cut into your newly created key, and then you copy the full line of the key, including the dash dash beginning and a dash dash end line. You copy everything and the key in between. You go to your GitHub repo, settings, secret and variables, actions. Then you create new repo secret. The secret is called SSH private key. You paste your key there, and that's it, guys. Once your key is pasted, you then push to GitHub, and as long as it hits your main, it's going to redeploy your app every single time. So you have your CI/CD set up, your server set up, everything all done, and this is going to save you so much cost because you can deploy all sorts of apps. You can run AI agents. You can use Node. You can run Python apps and every single thing. So I hope you found this video helpful. I actually have a bundled script of all my exact steps to creating the server, running of an app, and the CI/CD all packaged up. If you want to purchase that, the links are in the description below. If you know someone else that would benefit from this video, please help them and share it with them. That would be very helpful. And hope you like this video and see you guys in the next one. Thank you.